All right. Hi, everyone. My name is Damoon, and I'm here to talk a little bit about generative art, kind of what it is, why I think it's worth doing, and there will also be a kind of code walkthrough at the second half of this presentation. So if you have a developer experience or developer background, hopefully you can follow along, and if you don't, hopefully it will still give you some sort of insight into what generative art is. But briefly about me first. So my name is Damoon. I work as a lead developer at Freespee, and Freespee is a Uppsala-founded company. The entire engineering department is here, as well as like sales and support in central Uppsala, and we're currently hiring engineers. So if you're looking for a junior or senior or in between job, please reach out in the chat or freespee.com. But besides that, I'm also a generative artist and have been doing generative art for a couple of years. And for the last year or so, I've been fortunate enough to sell quite a few paintings as NFTs. And I'll touch on NFTs a little bit later in the presentation as well. But this will be mainly focused on the actual art aspect of creating art through code. And a lot of people have also referred to me as an all-around fun guy. My girlfriend disagreed. She told me that I couldn't put that in a slide. I told her I'd remove it, but I kept it in because I'm a fun guy. So what is generative art? The main concept is pretty simple. It's you put code into the computer, and the computer gives you art back as output. That's basically it. And there are a lot of ways to do it. Some very smart people have written frameworks for this. So processing is one way. It's a language and programming environment that is solely focused on doing like digital art and visual programming. P5 is another. It's a JavaScript framework. So if you're already familiar with JavaScript, P5 is a great place to start. And if you don't have a developer background, if you don't really know how to program, Touch Designer is a visual programming environment where you can drag and drop nodes and connect them and select different values just using like a mouse and get some sort of output. Personally, I like to use TypeScript and the Canvas API. TypeScript is a general purpose programming language, and that's what we use at Freespee, for instance, and that's what I use for personal projects. But you can use pretty much any tech stack that you like, that you're used to working with, as long as you can put a pixel on the screen. So why use a computer to generate art? So it's my belief, at least, that generative art is creative in a way that general software development isn't creative. So if you work in a enterprise software development role and you do stuff at an enterprise level or at scale, usually you work in the same problem domain or problem space every day. And that could be creating some sort of data storage solution or a data extraction or data transform, maybe write like a REST endpoint or REST API or GraphQL to extract data from somewhere, build a UI and a form. And it's kind of like it gets somewhat repetitive, even though there's creativity in that as well. You kind of solve the same problems with the same tools all over the place, and that's a good thing, because then you have a certain set of best practices that people can follow and build things at scale with. But generative arts, it's you get to face problems that you don't usually face, and we'll get more into what kind of problems those are. And it's also exploratory in the sense that you might not know exactly what kind of painting or piece of art that you want to create. You might have a rough idea of an algorithm you want to try, and then you start implementing that, and you see a result, and then you take that result and you feed it back into the algorithm and say, maybe I want to up these values or down these values, and we'll see some examples of that as well. And doing so, you can create kind of endless variations of a painting using things like using traditional software tools like Git. You can store copies of a painting and do some variations of that. You can undo things, which is hard to do on a canvas if you use Paint. And we'll see examples of all of these things in a second. So from here on, there'll be some code. So hopefully people can still follow along, and I'll try my best to explain the general principles behind this. So this is an output from an algorithm I wrote a couple of months or a year back, and this is entirely machine-made. There was no input from me as a human to build this, and it's a kind of interesting output to me at least. Everything kind of looks organic. There are very flowy lines through the entire canvas. Different lines have different colors, but they kind of still look like they belong together. There are no straight lines like around this edge. It kind of looks kind of man-made still. Some of the lines go outside the bleed area. And there are only maybe a handful, maybe 3 or 4 different rules that drive this algorithm, which are hopefully easy to understand because that's what we're going to go through now. And the main driving force behind this image is what's called a noise function. And this is maybe the most abstract part of this presentation. So a noise function is a function that takes a point in a grid, and for any given point on that grid, it returns a value between -1 and 1, so that surrounding points have similar values. So if you look at any point here, maybe this point 43 here, surrounding points will be fairly close to this original value. And that's true for any point. So this 0 will have similar surrounding values, and the further out you go, there will be more variance. And the seed function and the noise function will also take a seed value, and that seed is kind of like any random number generator or Minecraft world. It will tell the noise function what values to produce for what positions. And we can see that here, that if we produce a new seed, we'll get different values here, but the rule still applies that surrounding values have similar values. And we can do that for any given seed. And we can look at this in a different way as well. If we, instead of just drawing out the number as it is, we can convert that into angles. And here I start with the top left corner, and I draw a dot there. And on that dot, I sample the noise value for that position. And then I draw a line in the direction of the noise value. That's pretty straightforward. The problem is that this kind of doesn't look like anything currently. It's hard to see any type of cohesion or pattern. And that's because from the noise function's point of view, everything is kind of far apart still. And we can see that in the code here to the left, that if we take 2 points, which are only 7 pixels apart, the noise function will provide 2 wildly different values here, 0.54 and -0.08. But we can kind of smooth that out. We can trick the noise function into thinking that these 2 points are closer to each other by dragging this little slider. And all that does is that we divide the x and y values by some constant. And this will in turn give us a smaller x and y value. And if those 2 values are smaller, then the distance between them will be smaller as well. And we can see that if we kind of up this enough, at some point things will start to align. And now we can see that these kind of start to form a pattern. And if we drag it enough, we'll have a very uniform output. So this is just by looking at a value from the noise function and translating that to a angle for this arrow to point. And so far we have a kind of straightforward method of translating a value to an angle. And this is where the exploratory process kind of comes in. So now we can play around with these values and say, okay, what kind of result do I want to achieve here? What do I like? And then we also have this method of saying if a line turns a little bit, we can make it turn a little bit more. And if it turns a lot, make it turn a lot more. And then we can play with these 2 values in unison. And we can achieve a bunch of different effects. So already we have something that is kind of interesting to look at, or at least I think so, at least. Sorry, I'm trying to read the chat at the same time. So we have something that has great variety already, and the same rule applies that we can apply a new seed and we have even more variety, and we can do this an infinite number of times. And then we can take this one step further even. And here we have the exact same method, but we start with one line. And for that one line, we select a random X and Y position. And then we start by checking while that position is inside the canvas, sample the noise value, just like we did before. And then we move a set number of pixels in the direction of the noise value. And then we repeat the process. So here we have a line that starts here, goes to this point, this point, this point, until it reaches the edge of the canvas. Then we can try to start making this look a little bit better by saying, what if we take smaller steps? And the smaller the steps, the more smooth the line will start to appear. And at some point, we'll have this like perfectly smooth line that kind of flows through this field of values. And this is what's referred to as a flow field, usually if you do kind of generative art. It's a fairly common but interesting technique that you can do a lot of things with. So now we have one line flowing through this field, and we can still play with the other values like we did before, like we can up the smoothness. And again, it's an exploratory process. What kind of result are you looking for? Maybe you don't know. Maybe you look at the output from this and say, this is kind of what I want to achieve. And now we also have the ability to add more lines using the exact same process. So we can say add, I don't know, 100 or so, or 200 more lines. And now we have some sort of visualization of a flow field where at every point we kind of start somewhere, move through the field until we reach the edge of the canvas. And this is already kind of like interesting to look at. And we start to see like different patterns emerging. And we can play around with these values. And we have kind of great variety already. And then we can see these are the anchor points then. And then we can make the lines super smooth. So if we take this even one step further now, and this is where it kind of becomes a, how can I apply my programming knowledge to generative art? So in this case, we start just like we did before with just a single line. And for that line, we say, instead of drawing a line between points, we just draw the points as circles. And we can do the same thing we did before. So we can increase or decrease the size for each step. We get this kind of effect. And if the step size is small enough, we'll still get this uniform line that goes through. So we have overlapping circles. And we can see we still check for every step there. Are we still inside the canvas, or where should I place this circle? So we draw the circle, but then we also store the position of each circle. And that's kind of important, because if we know where every circle is, we can do things that when we add more lines, we can also check for collisions with previous circles, and we get this kind of effect. And now things are looking, even though they're entirely machine made, it kind of starts looking somewhat organic and also interesting to look at, where for every step, we just draw a circle. And if we're about to draw a circle somewhere that we've already drawn a circle, we stop. It's a fairly straightforward algorithm. And we can keep doing this an infinite number of times to achieve different patterns. And already here we have something that, I mean, it might not be nice enough to frame, but it gives you some sort of basis of, this is a painting I want to play with. And you can add more lines even to up the densities and make it more dense and interesting to look at. You can see like some lines are perfectly straight, some are bent. And for every variation, you have something else. So you have, in some cases, you have like this, I don't know, hill-shaped thing, and you can kind of look for patterns that are interesting for you. So with all this done, we can take it even one step further and start playing around with colors. And there is really no limitation in how you can color this thing. So for this presentation, I just took two kind of simple ones, and I set up a color palette, one color for the background, and then a set of colors for each line. And then I say, whenever a line starts, pick a random color from the color palette. And then we can do things like we can change the color palette, and it will give us some sort of result for this. And this is kind of looking like the original painting that we're going for now. We have different colored lines, everything kind of doesn't touch anything else, and we have some sort of uniformity and organic feel to an entirely machine-made image. But we can do something which I think is kind of more interesting, and that thing is we can try to divide this canvas into 4 regions, or any number of regions really. For this presentation, I just took like the top left, top right, bottom left, bottom right. So we divide it into 4 squares, one at each corner of the canvas, and then we assign each region one color. Yeah. So for anyone reading the chat, so Fidenza is an algorithm written by Tyler Hobbs, who is a generative artist who is really good at flow fields. He's written articles on it, and I can link it in the chat after the presentation. But he's a really good and popular artist. And the technique behind this painting is kind of like Fidenza or flow field based. So sorry, back to the thing. So we can assign a color to each region, and we can say whenever a line starts, check what region it starts in and assign a color based on that region. And now we have this kind of fun result, and we can still do things like change the color palette, and we can change the size between each step. And now we just have this magical create art button where we can randomize all these values, and we can say create something entirely unique. And each of these paintings kind of just live based on the input and these simple rules, and you have these entirely unique outputs. And this is you can kind of see how this is applicable to NFTs then, where people create something that takes like a block hash and uses that as input to generate these paintings, and that's what people are doing in spades right now. Fidenza being one of them, and a lot of other great artists are doing this. So going from this, you can do a lot of different fun things. You can create a bunch of different variation. And just to go through some examples of some outputs from this algorithm that I've written. So this is one example of an output from the same algorithm that I wrote a couple of months back. And you can instantly recognize it's the same pattern, but the coloring method is a bit different. It goes 2 regions, and the higher up the line starts, the more probable it is that the line starts as blue. And then there is also this color. I'm super colorblind, so I don't exactly know what color this is. But I mean, it's easy with generative art because you can use color codes for everything. So you can instantly see like it's the same painting, but it's a lot more structured. It goes top to bottom. You have a pattern that you can recognize. There's also this one, and the coloring method is kind of different for this. So for some of the lines, you use a color from the color palette. For other lines, you can check what's the noise value for this position where the line starts. If it's between a certain range, you can make the color red. And then you have kind of where you can see the noise field, how it kind of flows through this painting, but also each line kind of flows on its own. And you get this kind of effect. And this is something else kind of entirely where it's circular instead of rectangular. And personally, I kind of like this output. It kind of looks like you're looking through a microscope at something. And I want to warn that the next painting I wasn't allowed to hang at my house because my girlfriend thought that it was too suggestive. And I didn't intend to create this, whatever this is. I had an idea of what happens if I allow each circle to grow with every step. And then it came out like this. And that's also kind of a part of the exploratory process where you have an idea of what happens if I do this. I don't really know. And if you look at traditional media, like putting paint on a paintbrush or sculpting something, whatever you put on the canvas is what you get. There's nothing where you kind of go, oh, what happens if I just do something randomly? What's the output? And then you can use that output and feed it back into the machine and say, oh, this is something I like. I want to explore this more. And then finally, we have this, which is another take on the original painting that we started as a base image with. And again, we have different regions that determine what color we're going to choose. And lines kind of flow through, and we have some things going outside the bleed area. And I kind of like this result. It feels kind of natural, but also very constrained. And just as an example of another algorithm that I'm currently working on, so this is far simpler. The rules are even simpler, but I kind of like the output as well, even though it's kind of basic. So for this, I took a bunch of dots or points on the canvas, and I just placed them with a bias towards the top. So the further up we are, the more likely we have a dot there. And then I just started connecting dots, and I did more connections depending on how high up they were. So if a point is super high up, it will have more connection to its neighbors. And the further down, we have fewer connections and fewer dots. And we get this kind of gradient mesh, but it's kind of textured still. And I thought this was kind of interesting. And then I started playing around with what if we kind of create some force fields, and we place a force field anywhere on the canvas, and we say that dots aren't allowed in here. We kind of push them out, and we get this kind of effect. And then I wrote a bug, which was unintended, and I did the force field pushing thing wrong, and I ended up with this thing where it pushed things out, but kind of too far, and in directions I wasn't really expecting. And it yielded kind of interesting results also. And I kind of took this further, and then this thing happened where further down, things started breaking up. Dots were disconnected from this main organism, and up here, I don't really even understand how I created this. This was entirely unintentional. But that's kind of where I think the creativity part comes in, where you don't really have to have an idea of what you're going to build. That's a net negative if you do enterprise software development. You kind of do want to know what you're building, and bugs are a liability, not an asset in this case. So yeah, that's the majority of the presentation. The main goal I had with this was that I would love it if more people got into this field. There are communities for it on Reddit, for instance, and on Twitter. Reddit/r/generative is one of them, or creative coding is another. So there are a bunch of resources, and there are and Twitter has creative coding and generative hashtags that you can follow as well. But if you're a software developer and you're looking to just create something, even if it's just for yourself to hang on your own wall, I would strongly suggest trying this out, and just playing around with what can you create in whatever language you like. If it's Go, or if it's TypeScript like I'm doing, or processing, which is easier to get into, or Touch Designer, that's something I highly recommend. So if you have any questions for me, I'll hang around in this chat, and I'll be in the metaverse and trying to do the after talk thing, where it's called the Hangout. So yeah, thanks so much for listening, and goodbye.